Okay, so rescuing yourself from disaster. I'm sure a lot of people are going to have seen this book before, right? The Design Patterns book. If you haven't seen this book before, you're not quite sure what it is, don't worry, we can talk about that. But it's a hot topic at talks and conferences. People like to kind of say, oh, I know what design patterns are, I'm going to do a talk on them. And if you don't know what they are, they're common ways of solving familiar problems in software engineering. And you can go to this series, Solaricast.com has got a really good series on design patterns. It kind of gives you about 4 or 5 of them, kind of talks you through them in PHP in a familiar kind of way and tells you why they're essential or what problems they solve. But tonight I'm going to be talking about anti-patterns. Now, the anti-patterns book came out about 2 years after the design patterns book came out. So if design patterns are ways of solving problems in software, what are anti-patterns? Well, anti-patterns are common ways of solving familiar problems in software engineering that have an unintended negative result. It means basically we keep making the same mistakes over and over with, we hit the same dead ends. And spotting anti-patterns helps you identify where things have gone wrong, and they put you back on the right path. So when you started out with ideas of building something grand like this, but what you actually ended up with was something like this, and your project manager looks at you every day crying, and you go home feeling grumpy and fed up, you're probably suffering from a lot of anti-patterns within your system. Now, the anti-patterns book defines 3 different types of anti-patterns, 3 different classes. They are software development, software architecture, and then project management as well. So there's a lot of scope for us to get things wrong as people. And we're going to go through examples of the 2 software types, so I'm not going to bother with project management tonight. So the book also gives us kind of anecdotal evidence of how to spot these kinds of things. So if you're in your, not that anybody is at the moment, but if you're in your communal area at work, obviously staying 2 meters away from everybody, and you kind of overhear somebody saying to somebody else, I thought you'd already fixed that bug. I mean, that should be like a prime indicator of something that you can look at to find something that's gone wrong somewhere. Because just this kind of sentence here, I thought you'd already fixed that bug, is a prime indicator of cut and paste programming. Now, this is a really simple one that we're going to start off with, right? And it does get more juicy, so bear with me whilst we go through this. But cut and paste programming, the symptoms of this is you've got the same bug recurring throughout the system. Despite you fixing it, you fix it in one place, but then you have the same bad behavior somewhere else, and you fix that one, and then you find it somewhere else, and you get all these, you think they're regressions, but actually it's just the same thing over and over again in different areas. Your lines of code increase more than your productivity does. You know, you've got a disproportionate increase in functionality versus the time spent actually programming it. So you're putting so much more effort into programming than the gains you're getting on the way back. And you tend to find that you've got excessive software maintenance costs. Stuff just costs more. And the causes of this, or the typical causes of these, things like organizational emphasis is on short-term payoff rather than long-term investment. You know, it's a kind of quick throw it over the wall, get it out there kind of attitude without ever actually going back and sorting things out. Development speed may be a top marker of productivity in your organization. Like wrongly, your managers might be thinking, if you're not pushing out 100 lines of code like a minute, then you're not working hard. And then lack of abstraction or poor understanding of OOP principles really comes down to inexperienced developers. And another typical cause of copy and paste programming is Stack Overflow. And it's people who, when they're unfamiliar with new technology, it's not just Stack Overflow, of course, but it's, you know, when they're unfamiliar with new technology, they just copy and paste examples from the internet and they just modify it to their needs. And there's, I'll post the link to the thread after this, but there's an interesting Twitter thread about how Docker for Windows wouldn't work if some video card driver management software was running at the same time on the system, and the result being that 2 developers needed to achieve the same thing and both copied the wrong example from Stack Overflow. And it ended up just meaning that Docker wouldn't work if this video card management system was running at the same time. So how do we solve these kinds of things? So copy and paste programming, we solve by doing some code mining. Now, luckily enough, I mean, nowadays PHP Storm actually kind of gives you an indication when you've got duplicated lines of code. But what you can do is just require the copy paste detector in your project. So PHP Storm has had this since about a year, since 29.2 version, but the copy paste detector works pretty well as well. And so if we put that into a project and we run it, we obviously exclude the vendor directory. And I ran this on an old project that I worked with about 6 or 7 years ago. And it said to me, I found 35 clone files with 1,873 duplicated lines in 44 files. And it helpfully as well, this tool kind of shows me exactly where it's found them. And when I look at this output here, I kind of realize can start recognizing some kind of hints as to where we should look at stuff. So we've got this thing called campaign groups, and we've got this thing called campaign, and we've got this thing called a class called manage campaign groups and a class called manage campaigns. Now already I'm kind of thinking maybe somebody took something called manage campaigns and wanted to make a collection of them and just went, oh, let's call it manage campaign groups, you know, to make it pluralizing something. Helpfully as well, it shows me exactly where to look for these duplicated lines of code. So the next thing to do when we know where to look, we can start refactoring. And the way to do it, the way that the book tells us to do this, quite simply, is just to pluck out reusable components. So if I look in this manage campaign groups file, I can start off just by clicking on some of the method names in here. And again, so PHP Storm quite helpfully says, this actually isn't used anywhere. So then in that manage campaign groups, most of the methods are actually unused. So I could just delete a whole load of unused code really, really simply. And it left me with one method between both classes, one method that was actually used in both places, and it's called this pass filters array thing. And it defines some sort of algorithm for getting filters. That's all it does. So this is the managed campaign groups, and you can see managed campaigns. It's basically the same. The only thing that's actually different is the content of the array. And for good measure, I found it in a third place. This is how much copy and pasting was going on in this code base. So to fix it, I can just create an abstract class called campaign management here, and I can create a static function called get filters, and I can define the algorithm that I need in that abstract class and say that any concretion of this class needs to provide me with this method. So I can say that all the common stuff is in this base class, and the only thing that's different is that array, and it's up to the clients or the concretions then to provide me with this that we use. So we've got this here, and of course this method just returns that array each time, and that will be the only thing that's actually different each time. And we can run this thing again. So after just doing that really quick fix, that took about 5 minutes to do when I did it, just run it again. And you can see actually we've got 4 fewer clones, and we've removed nearly 450 lines of code. And that would save a lot of developer time in trying to fix bugs, recurring bugs, and this, that, and the other, because there's only one place to change the bug each time. So how would we stop this happening in future? Well, it turns out that actually just do code review, and make sure you're doing better code review. Actually get people looking at code before it gets merged in, because somebody on the team will recognize that they've already done this, or that they've done something that can be made into some sort of kind of reusable component. So that's already easy one that we've gone through there, and I'm sure people are thinking, oh, well, give me the good stuff. How do we really actually apply some learning to what we're doing here? Well, say for example, you're still 2 meters away from this person in the communal area, drinking coffee with them, and he says something like, we're not really sure what that code does, but it just works, so we leave it alone. Now, I'm sure everybody has come across this kind of situation before. This is known as a lava flow. Now, lava flows are kind of pieces of code that nobody really knows what they do anymore. Everybody leaves them where they are, and they just kind of solidify into the code base, and they become really hard to chip away at and remove from the system. Symptoms of that is that you might have undocumented, complex, important looking things in the system that seem unrelated to the architecture. You're thinking, well, why is that though? I'm not really sure why it's there. What does it do? You might have variables and code fragments distributed throughout the system. Again, that nobody can really tell you what it does. And it may well be as well that the person who wrote it left the company, or has moved to a different team, or isn't contactable or anything like that. And these things kind of just get left in because nobody wants to break the system. You might have lots of to do or to complete comments within the code. And a massive indicator of this is that you've just got large blocks of code commented out with absolutely no explanation whatsoever. Now, causes of this tend to be things like research and development code finds its way into production. You might work on something to try out an idea, but never actually go back, and you never throw away the idea stuff and create a proper version. You just go, oh, it works, we'll throw it in. You might have lone wolves working on the code. So these are people not talking to each other. Like, everybody has their own idea of how to implement something, but they don't share ideas. Shifting goals of a software project. If you're not really sure what the end goal is, what the product requirements are, then you're going to end up putting stuff in thinking, oh, I'm not sure if we're going to need that, let's comment it, let's leave it there for now, maybe we'll take it out later, and you'll have something like a comment with like temporary, remove this later on or whatever, because we all know that temporary comments are never temporary. And a lack of architectural forethought or design as well kind of leads to this, because if you don't really know how to do architecture, then you're going to be trying a lot of stuff and then commenting it out and leaving blocks and bits and pieces in. So when you're faced with this, what you really need to do is actually take the time to dig into the problem. So this is an old Symfony 1 application that I worked with some time ago. If anybody's old enough to remember Symfony 1 or still has a soft spot for it, this is an actions class, which is the same as what we have controller classes now. And we can see here we've got this quite large block of commented out code in here. Now, this is a company that no longer exists, so I don't think I can get in trouble for showing it to people on the internet. I've shown it 3 or 4 places and nobody's come after me just yet. But we've also got these 3 methods at the end here that make no real sense. We've got download old and download an old download. I mean, what the hell's going on there? How that ever passed code review, I do not know. But it makes no sense to have these things here. We need to try and dig in and find out why these things are there. So how do we refactor this and make more sense of it? Well, we can do some detective work. Now, when I put this talk together, I didn't have access to the original ticketing system anymore. So I had to think about what tools I had at my disposal to dig into what was actually happening and why this system was like this. Luckily, Git is really good for this. So Git is a great tool that I'm sure everybody's using. And everybody, I'm sure, is writing fantastic commit messages. But if we do a git blame on that actions class, we can see here that this is a long time ago, you can see, but on one day, Geordie added all of this code, and on the very next day, he commented it out. Again, why this was merged and put live, I do not know. Why nobody said, why are you commenting this all out? It's up to that. But luckily, I mean, we've got this commit hash here, so we can just click through that and have a look. So we git show, let's see what was going on. Let's see if we can figure out what Geordie was thinking when he commented all that code out. And we've got this commit message. Luckily, he's put in a commit message that gives us enough information to start thinking about things. And the very first thing to do is say, oh look, he's added this task class. Now these are like Symfony commands in modern day. That's what we have, these tasks. So the commit message is, I've added a cron and he's added this task class. And if I go in here, well, I actually found that the code in here was a verbatim copy and paste of the stuff that he had commented out. So quite clearly what he'd probably done was found that his action, his controller method, took too long, and it was worth actually deferring this to some sort of asynchronous process and creating a task class for that. But it looks like he probably wasn't confident enough just to remove all of the code in the first place, and that was why he commented it out. Maybe he didn't think things were going to work. And I remember working for this company that a lot of the time we did debugging in live. So the easy thing to do is just delete all of that code that was commented out. We don't need it. But now I want to do something about these three methods. So I can log what happened to this actions class again, and I found the two commits that were actually relevant to those lines. You can see here that they've got very similar commit messages. They've got sequential ticket numbers, and now if you take time zones into account, they were committed 2 or 3 hours apart from each other. So this is kind of indication of lone wolves where the developers aren't talking to each other. You know, they're solving very, very similar problems, but they haven't actually discussed it whatsoever. And maybe a morning stand-up or a check-in where we talk about the stuff that's upcoming or whatever could have solved that. So we can just show one of those commits, the second commit, I think that was. And this was a kind of a relevant patch here. So you can see here we've got this Excel thing. Now I recall from this project we had Excel downloads of campaign performances. So we had CSVs and clients could download Excel spreadsheets of stuff. So we've got this download old thing here. So he's renamed the Excel to download old. We've got this new download thing for the new Excel, which is just called download. And there's something about permissions. So it looks like there's something about having permission to download a new version of something, and the current version's been renamed to old or something like that. There's some sort of versioning thing, naive version thing going on here. So if we click through here, it turned out actually that download old and old download were pretty much just clones of each other. One developer had added one, the other one had probably found that he couldn't take the old download method name and called it download old instead, but they were identical. So we can get rid of one. That still leaves us with a problem here. We've got execute download and execute download old. So what happens when we get a new format? Again, so an extra new format. Are we going to call it old download or what? Well, simply enough, we can just start naming the methods. A very easy fix is just to name the methods after the version. Like if you're going to call it by something, then just call it that in the in the control direction. It's not perfect, but at least it's a damn sight better than what it was. So how can we stop this kind of thing happening again? Invest in educating your developers. Your code doesn't get better if your developers are still solving the same problems in the same ways and using the same bad techniques. You've got to actually make sure that your team is getting better and progressing. Also, redefine the architecture whenever you see a lava flow forming. You have to have the confidence to pause your feature work and spend time refactoring. If you think actually this is slowing us down, it's becoming difficult to work with, stop, break parts out of it. And that's how to deal with a lava flow. So now again we're in this communal area, and you're over here from a few meters away. Somebody say that code is an absolute mess. Making a change in one place breaks something in another. And again, I'm sure everybody's had experience with this, especially as when we were all junior developers and starting out on our career paths. I'm sure we made a lot of spaghetti code. I know that those are noodles in the image, but it was the best picture of spaghetti that I could find on Unsplash. So deal with it. Symptoms of spaghetti code is that you cannot reuse it. It's impossible to reuse. It's also very, very difficult to test. Objects are frequently named as processes. So you'd have classes maybe called something like get the latest results.php or something like that. It talks about what it does rather than what it is. You've got minimal relationships between objects, like with kind of really tenuous links. Many object methods take no parameters, and they use class or global variables. There's probably a lot of methods that are mutating state on objects as well, or trying to access the internals of a class where traditionally that would be a bad idea. Staff with a good OOP background, they don't hang around for very long. They don't bother to stay there and fix stuff. They come in, they go, this is a mess, I'm not working with it, and they go off somewhere where they're a little bit happier. and there are just side effects everywhere. And of course, the application is going to perform really badly. So the example I'm about to show you of this was for a company I worked for, and it took on my dev machine, it took about 30 seconds to load a page. And I was trying to work on this page, and I said, like, it takes 30 seconds to load this page. I need to refactor it. And they said to me, no, don't bother. We'll just buy a bigger server. And I said, look, if it takes me 30 seconds to test this page, I can only make two edits a minute. Like, we need to do something about this. So the causes of this kind of thing is programmers are new to OOP. They don't kind of really understand it. They lack experience. Code reviews may be non-existent, or maybe you're only touching kind of code style. They're not actually really digging into anything useful. Maybe inexperience of architectural design. Your system architects maybe not that great, or need to kind of come up with some new ideas. And again, lone wolf developers in isolation. Now, I find as well another symptom of spaghetti code is you end up with commit messages like this. Again, because nothing works on live as it does on dev, and nothing works on dev anyway, and there's probably no tests either. And I don't know if anyone's spotted it yet, but sometimes quitting Vim is hard as well. So let's look at some of the code that we had from this. This was an application that is a PHP application with a custom framework that was also served with about 300 mod rewrite rules behind WordPress. So if Apache didn't match the rewrite, it went to WordPress. If it did match the rewrite, it got sent through to this. So this was an example class. It was just a bunch of functions. It didn't even have a class structure really. But we've got some things happening here that we'll talk about. We've got this method called get new PDO instance. Now make a note of that because that will come back to us in a minute. We've got some global variable things going on here. We've got in here as well, we've got that new PDO stuff. We've got this client thing. You can see here, we've got this create client method that's being called, but we don't know what we're meant to send it. Like, where we're calling it, we're sending it a username and an email, but where the method is defined or the function is defined, it only wants an email, but it doesn't define if it wants a string, an array, or what. We simply don't know what the correct behavior is. Again, yeah, so like I say, we've got this get new PDO instance stuff going on. Just for fun, we'll make sure this always returns true. And then we look at this. This was the front controller of the application. We've got a lot of mess in here, really kind of messy. Debugging was kind of a bit of a joke, I think, from the guys who wrote this originally. And if we look at the database connection stuff, we've got some stuff in here as well. So we've got this method here, get new PDO instance. This is where it's actually defined. We're requiring some sort of master config thing, and we're saying, okay, so we're inheriting some variables from that master config. And then if the database that we want is in this set of names, then we just immediately overwrite them. If it's this other database, we immediately overwrite that as well. And then for good measure as well, if it's this other database, we immediately overwrite that. And we had, I think, about 4 or 5 databases in this system, and it was just an absolute mess. The config file was so easy to make a mess of and just break absolutely everything. And let's, of course, always make sure that we show the errors to our users. Now, here's the thing, right? Where I said that get new PDO instance was noteworthy, is because every time we ran a query, we created a new connection to the database. And no wonder this thing was so slow. Some pages were making a couple of 100 queries as well. I'm not going to go into that, but it was ridiculously slow. In the master config file, it was just a collection of variables, and this was, like I say, it was so easy to make a mess of this. So how do we even think about refactoring something like that? The first thing to do is just take a lot of drugs and hope it goes away. Failing that, encapsulate elements with getters and setters. Start building structure into the system. So this master config file, I mean, it's not brilliant, but we could just make a config class. Okay, fine, we're going to commit something that's got knowledge about the system inside it, like if we start doing that. But you know what? It's moving in the right direction. We can always remove that from Git. We can change passwords and remove this knowledge from Git when we need to. We just need to start adding some structure. Doesn't have to be correct. We just need to start going in the right direction. So now we can create like maybe a database class and start thinking about, actually, let's put in the names of the databases that we have. Again, we're just starting to encapsulate stuff, remove it from this kind of mess of stuff that can be misconfigured and put it into something that can be at least given some kind of structure and some sort of predictable behavior. So we're going to start adding the names of the databases the system might know about. This was also a really good way of finding out that there are another 3 databases that weren't documented that the system also relied on, which were running on other servers somewhere else. In here as well, we can start guarding the application. We didn't have any guards in before, but we can actually say, you know what, if the configuration is wrong, I'm now going to start throwing exceptions rather, at this level, rather than bubbling all the way up to the application. And we can now start actually reusing connections. We're going to say, if we've established a connection from here, let's return it. And then in the database, database class, we can create the connections using that config that we've already created. So straight away, we've separated the DB stuff from the config stuff. We've actually started creating a separated structure. It's still quite highly coupled, but it's less coupled than it was. Now the repository stuff now can actually start just reusing this. So I can say when I want to do something with the database, I can say, give me the connection for this database, and it's going to go and give that to me. I need to inject that database class in, but again, like I've got something that's going to be predictable and reusable. So now we do the same thing that we did with the copy and paste code. We start, once we've got some structure in there, we can pluck reusable components out of it. And we can use that approach to tidy up this bit with this create client thing. So like I said, we've got this, we don't know what we're going to pass through. What does create client want? Does it want the email? Does it want this, that, and the other? Well, as we're doing this, let's remember, even consistent bad code is better than inconsistent spaghetti. So what I can do is just create a client class that I can pass around. It's not brilliant, but it's going to be some kind of value object, immutable system that takes some stuff on the way in and has some getters on the way out, and at least then I know that I've got, like I say, something encapsulated and solid in that respect. So then the repository can just go, you know what, I'm just going to use this client thing. I'm going to pass that all the way through. I don't need to know anything about the client's internals. The only thing it needs to know about what the client can do is the stuff that uses that class. And we identify and eliminate lava flows as we go. So if you're working on something, you find a lava flow, go and refactor again. It's about having the confidence to stop work and say, you know what, something's going to go wrong unless we deal with this sooner rather than later. And how do we stop this kind of thing happening? You need to take time to analyze the domain before you start work. So understand the requirements of the product before you start. So don't chop and change. Don't put stuff in and hope that it might be useful later on. You need to actually know what you're building. And again, develop a model before implementation rather than concurrently. So don't overplan it, don't waterfall, but have an idea of what you're building and what the architecture should look like before you start doing it. So now we have one. This is one of my favorite ones. You're there, you're chatting to your mate, and he says, don't touch that class. And give me a virtual hands up if you've ever had a conversation like this. Don't touch that class. It's the heart of the application. If you've ever had something so big and so scary that you're just afraid to touch it, and they're usually untested as well, these things, because nobody knows exactly how to test them. Now this is called a blob. Now the trouble with blobs is that they're usually a single class with a large number of properties and methods. It's more than 60 is typical. There'll be a single class encapsulating a disparate collection of properties and methods. So nothing really within a class is related to anything else, or maybe the class has got too many responsibilities, like visually too many responsibilities. You can see straight away it's trying to do too much stuff. The class might be inefficient or excessively complex. You can't reuse, you can't test it. It's probably going to be some very point-to-point direct implementation of something. And it probably is really uses a lot of resources, even for doing really simple stuff. And causes of that is that functionality is added piece by piece without actually refactoring anything out, without noticing where you can apply some design patterns and make things better. A lack of object-oriented architecture, lack of any real architecture whatsoever, and lack of architectural enforcement. So nobody is saying, you know what, let's go and do this. Let's try and apply this design pattern. Let's try and do this, that, or the other. You know, we should refactor this. So, you know, it's a kind of lack of anybody having that foresight or the knowledge to do this, maybe the lack of experience. So we're going to look at a particularly juicy example of this. This is a class that I wrote a long time ago. Before I knew what a factory class was, I understood that I needed to write a class to generate something and just called it a factory for the hell of it. I thought, yeah, well, it generates something, it must be a factory. And this was a class that needed to create reports from an SQL database, from MySQL. It was so bad that it had to have documentation inside the class of how to use it. It was configured by passing arrays and strings through different methods. And the absolute worst part of it, or one of the worst parts, was that the client of the class needed to know about the internals of the class in order to be able to use it. I mean, it was ridiculously bad. I had developers would come to me and say, wish me luck, I need to go and add something to Report Factory. Or, you know, the joke was that if you needed to do work on this class, then you'd take a day off first, you know, to prepare yourself for it. It was awful, honestly. But the idea was that we needed to generate SQL reports. We had events from social media campaigns coming through. So one by one, we'd have some sort of event, like a click on an advert or a video view or something like that. And we needed to generate reports that were pivoted and aggregated. But the SQL for that took forever. It would take 5-10 minutes to generate a report, and that was being called from a controller action class. So it was ridiculous. You couldn't expect people to wait around for that. What we worked out was that if we created temporary table structures, then we could speed this up, because we can index the temporary tables, and rather than 5 minutes, it'd take maybe 10 seconds to generate a report for download. Now, of course, there were much better methods of solving this problem, but we just didn't know them at the time. And you know what? The temporary table thing worked. We spent about 3 weeks trying to figure this thing out, and it worked, so we went with it. But the temporary tables had to be created in a specific order depending on the report type, and that was why the clients of that report factory had to know about the internals in order to be able to get hold of the report that it wanted, because it needed to say, I want these tables generated in this particular order. So before we even think about refactoring, and once we've had our day off to prepare ourselves for going in there and doing this, what we need to do is think about identifying relationships according to contracts within that system. So if you look at a blob class or a god class, you tend to find, actually, if you just list the methods, there's usually a lot of stuff that probably makes sense together. So in here, we've got methods about creating these temporary tables. We've got methods about actually selecting from those temporary tables. And we've got some sort of query builder thing going on as well. So when we come to refactor this, what we need to do is actually identify natural homes for those contracts. So we can sort this query builder stuff, and I'll just create a temporary namespace to make this mess in whilst we do the tidying. So I'll create a query builders class and just throw those methods into there. We'll get them away from that report factory and put them somewhere else. That's the very first step that we take. Now the report factory depends on those query builder methods. So we need to say, actually, when we have this report factory, we need to have a query builder as well. Okay, fine. We've added a dependency here, but we're going to make a mess before it's going to get worse before it gets better. Just be aware of that. So the controller now also needs to know something about the query builder because it's doing that stuff about I need this and I need those things. So the controller now has even more knowledge of the internals of that report factory thing. But fear not, because we will sort this out. But we can go back now and remove this from here. If we look now about this temporary table stuff, we can just throw that into a temporary table class. Again, it's just a case of removing it, putting it somewhere where it's less scary to deal with once it's there. And then we can have this create temporary tables method that takes that report type and just does that algorithm for setting those temporary tables up in the correct order. And again, we can just remove those from here now. And so the report factory is just kind of left with being a bunch of methods. And we can just put those into like a kind of metrics query thing now. So the report factory is basically just a constructor and 1 or 2 utility methods now. So the metric query stuff can be responsible for defining what it needs. That's all it has to do. So now we can think about removing those couplings that we've added. So it's pretty helpful, I think, to draw a diagram of what we've got. So we've got the controller, which has a dependence on the report factory. Report factory has a dependence back on the controller. And of course, after what we've just done, they both have a dependence on the query builder. I mean, it's pretty messy. We've got this metrics query thing. We're not really sure what that class does, but it's just a collection of methods. And that has a dependence on the temporary tables. And the temporary tables also has a dependence on this query builder. So there's a lot of mess that we need to kind of think about sorting out. But if we take it step by step, and the book describes how to do this, if we take it step by step, we can overcome this. And we're already halfway there, to be honest, with what we've already done, just by grouping stuff together. So let's think about what we can do. Well, maybe if we make an abstract base report class, then we can create specific report classes being responsible for what they need. So if we make that abstract, we can just say, set the query conditions. So if I get a report for, I don't know, some sort of campaign type, then it can just say, I need these query conditions, go and set it up. And then the get report method can use that abstract function. And this then becomes the same as we did earlier on for the removing the copy paste code with that template method pattern that we used. We can just do the same sort of thing. We've got an algorithm, we'll just change what goes into it. The controller then only needs to ask for the type of report that it wants. We've suddenly removed, I'll go back a slide, we've removed all of that from the controller. We've just got a simple API into what we need now. And if we look at this, what have we done? We've created this metrics report thing that's got couplings. The controller needs a metrics report, but it doesn't need the report factory or the query builder anymore. And so this metrics report, maybe we don't even need that query builder. Maybe we should just get comfortable with writing SQL. So we can do that. We can change that get query conditions to get query, and that can just return what it needs. So in that case, then we can completely get rid of that coupling to the query builder. And actually, if we think about it, that metrics report doesn't need the factory at all. We've actually now dealt completely with that block. We've removed it from the system. We've still got a bit of mess though, so let's think about what else we can do to remove some of this other stuff that we've inherited from that class. And just for fun, maybe we can use the decorator pattern. That's a decorator. Maybe those temporary tables can be used with the decorator pattern. It's just like I say, just for the fun of it. So if we have this temporary table, SQL.php as an interface, then we can just extend that or implement that even and just say each time this get SQL can create the table that we need and concatenate it. Yes, it's horrible. It doesn't need to be perfect. I just need it to be less bad than what we had before. So it doesn't have to be perfect, just less shit. So now, if I've got this metrics report and all this kind of dependencies running all the way through, well, I've just got an interface now. The metrics query only depends on the interface that we've got there. And thinking about it, well, that interface can't depend on the query builder. So we've completely refactored that query builder crap out as well. And then if we think then about maybe if we use the temporary table classes to create the intermediaries in the order that we need, we probably could then have each concrete report class defining the order that it wants those tables to be set up in, and as part of this algorithm, and we actually don't need that metrics query stuff at all. So then we just have a bunch of temporary tables. It's still a horrible solution on the database side of things, granted, but we've actually got something that's much nicer refactored in the PHP side of things. And it means it's testable as well. We've gone from one huge untestable class to a bunch of small, focused, solid classes that we can test. And then the next thing to do is to delete that old reporting, that temp namespace, and leave us with the stuff that we've got left over that's actually useful to us. So how do we stop this happening before? Well, again, code review, you would be surprised to find out how much crap code review keeps out of your system. So we're pretty much at the end here. I've tried to keep it quick, so I didn't want to take up too much of your time. A few notes on this, though. The thing to do, always pick the low-hanging fruit. Use the 80-20 rule. So the 80-20 rule, you can look at it in two ways. One way is that the last 20% of the work takes 80% of the effort, or the inverse of that is you can do 80% of the work for 20% of the effort. So always find the thing that's causing most of the slowdown, put 20% of the effort in, and no, put 20%, always put 100% effort in, of course, especially if your CTO is on the call here tonight, as mine is. Always put 100% effort in, but you know what? It only takes 20% of the effort to deal with 80% of the crap. Learning experience, hire people from different backgrounds, not all the same. If everybody's got the same experience, the same approaches to stuff, you're just going to golden hammer, and golden hammering is another anti-pattern where you just always apply the same solution and never question what you're doing, and you're going to paint yourself into the same corners each time. And invest in training the developers. Like I said earlier, the code doesn't get better if the developers don't get better, so make sure you do that. And you need a strong leader and an experienced decision maker to be able to say, you know what, that's the wrong way. This is going to be a better way of doing things. But equally, somebody who's going to listen and say, maybe you've got a good idea there. Maybe that's going to be a good method of achieving this brand new problem that we're solving or something. But mainly it's teamwork. Make sure that you lift each other up. Make sure you support each other. Make sure you fail together and you succeed together. But it doesn't stop there, of course. There's a sequel anti-patterns book as well, because we also suck at designing databases as a race, as a human race. But of course, tonight is all about anti-patterns, the software stuff. And you can get this book quite cheap secondhand. I think brand new, it's about 50 quid, but you can get it secondhand for about a tenner. And I would certainly suggest doing so if you recognize any of the problems in there. There are also resources online where you can find a selection of the anti-patterns and the refactored solutions, but I think the book probably goes into much more depth and is just a really good resource to kind of figuring out how to solve these problems.